We got 5 more minutes to wait, and we'll start right at 3 o'clock Eastern time. So just a little bit. We're about to start. We've got about 2 more minutes and then we'll start, okay? All right, everybody. This is Pure Air Filtration. I'm Paula Westmoreland. I'll be talking about protection of corrosion for mission critical electronics today. If you have any questions, just wait until the end of the webinar, and then you can either raise your hand or go in the chat. We'll unmute you, and then you can ask your questions. So if you don't mind, just wait until the end. I've been in this arena for about 20 years in commercial industrial gas phase filtration industry. So I'm going to talk a little bit about who Pure Air Filtration is, what do we do, what kind of products we have, and then how we use our products for corrosion control. So starting with who is Pure Air Filtration and why are we set apart from our competition. First of all, we are single source manufacturer. That means we make our own systems, we make our own chemical medias, and we also have monitoring systems for the gas phase filtration. We are ISO certified. We serve multiple markets and applications, and we customize every product that we have based on the customer's need. So a lot of times there are even different markets and same markets and same applications where we're going to use different products and different solutions depending on size restriction and depending on the way their system is set up and how old their rooms are and things like that. So in regards to the adsorbent families that we have many medias that we make. So those are, between carbons and engineered carbons and engineered medias. They all they're used for different gases. So the other thing that we do is monitor the adsorbent consumption. So there's different ways that we do that, and I'll show you guys how to do that after an equipment is made, a media is put in, and the system is in use. And then we have our laboratory testing where you can do media life analysis and you can do coupon kits of things like that. So first, talking about gas phase filtration. What is gas phase filtration? There's different types of filtration. There's solid filtration, and we're talking about, particles, dust and smoke and things like that. Liquid filtration, and then there's gas filtration. So when you're talking about microns, you're talking about a 1/1,000,000th of a meter. That's a very small amount of particle or gas or liquid. So the gas phase filtration is the process of using specialized filter media and chemical substance to remove gases, pollutants from the air. So that's where we concentrate our know-how and our equipment and our systems in. Most gas phase filtration systems have absorbent medias, the chemical medias to remove the gases from the air. Some of the gases that you hear a lot are like hydrogen sulfide and sulfur dioxide and sulfuric acid, chlorine, ammonia. So those are some of the gases that we filter with our systems, but there's many, many, many more. So the gas phase filtration, it's removing the molecules of gas from the air. So how do you do that? You use our chemical media to do that. Again, some of the gases removed are H2S, SO2, chlorine, ammonia, VOCs. So when the contaminant air hits the media, there is a chemical process into the media where it's going to clean that gas, and then on the other side, you're going to have purified air. So there's different chemical filtrations of different medias to target different gases. So not all applications are the same because most of the time you have different gases that you're trying to filter. The difference between physical adsorption and chemical adsorption. So the physical absorption is mainly what happens with carbon or activated carbon. And that is the molecule gets into the surface of the carbon, and then it just kind of adheres to that outside of the carbon. It just sits there. There's no really chemical changes. And that is reversible, which means is if there's larger molecules that come through the air, like humidity, it's going to make the gas desorb from that carbon, and you're going to get, and it's going to hold on to the water or to the humidity. It's kind of like a sponge. The chemical adsorption or chemisorption is a permanent and irreversible process, which means when the gases get to that media, get to that pellet, they are going to infiltrate that pellet. There's going to be a chemistry change within that pellet, and those are not going to be, it's going to be entrapped inside of that pellet and is not going to come out. By the time that change is done, the gases, that molecule is totally different than what it came in. So that process is permanent and it's irreversible, which means after the gas sees and penetrates that pellet, it's no longer going to be H2S. So that's the difference between activated carbon and then engineered media or chemisorption media. So some of the difference again between carbon and engineered media is carbon is not UL certifiable because it can catch on fire. Engineered medias for the most part are non-hazardous after spent, and they will not catch on fire. The carbon is a reversible process, which means it can desorb that gas after the fact. The engineered medias is irreversible. That means after the gas goes through, that gas is not going to come out on the other end. Carbon is hazardous after is used. So when it's not landfill safe. You cannot just put in the landfill. Engineered medias most of the time are landfill safe, which means you'll be able to send to a landfill at no problems because it's not going to desorb. The carbon is extremely difficult to determine media life. Engineered medias is not. You can do lab tests to find out exactly how much media is still left, because what do you do is you check the amount of impregnation on the media itself to see how much is left. So there's different types of medias out there. Of course, the carbon's a lot cheaper than the engineered media, but sometimes, like for VOCs, you have to use carbon because engineered media will not work for that gas. So it's sometimes you have to do a combination of those two. Sometimes you just use the engineered media. Sometimes you just use just carbon, depending on what gases you're going to use. If you have the choice, engineered media is your best choice for filtration. Some of the medias that we have, they range from aluminum impregnated with potassium permanganate. Some of them are 4% potassium permanganate, some are 8, some are 12. We also have the activated carbon. There's two types. There's the bituminous carbon, and then there is the coconut shell carbon. So those are both activated carbon. There's engineered carbon, which is also impregnated carbon. There's the mineral base media that is very cheap, but then it has some issues with that as well. And then we also have blended medias. That is what I was talking about in regards to we mix the carbon or the engineered carbon with something that's impregnated like potassium permanganate, depending on what we're going after gas-wise. And our emergency gas scrubbers take safety sorbent, that's mainly for chlorine. So there's different types of media that goes after different gases. We don't have all the list for the gases that we have because the list is so big. So if you have a specific issue with a gas, we need to know what that is so we can know exactly what media to use for that. So some of the part units that we have or filters that we have, I'm going to go from the lowest amount of media in them to the highest amount of media. So a carbon plated filter, which is a combination particulate and chemical filtration, there's media inside of there, so you can put activated carbon in the plated filter, or you can put a combo filter with activated carbon, potassium permanganate. Again, depending on what the application is, where you're going after, what kind of odors you have, what kind of contaminants you have. These filters are used for very low amounts of contaminants, and a lot of times is for system that's already in place that you're trying to retrofit, because initially when you put that HVAC system in place, you don't know that you're going to have odor issues. You don't know you're going to have gas issues. So those might take place of just a plain particulate filtration filter. So you might put a combo filter in there. And on the combo filters, you have the gas phase plus the particulates. So you have the same things as you do in a particulate filter with MERV 8, MERV 10, MERV 15, and then it comes with box style or 1-inch header, and then the different depths of the filter, 2, 4, and 12 inches. Those are the most common ones. So those are some of the filters that we can do as an initial setup. Or, for example, if you have a hospital and they were re-roofing the building, and that is just a temporary fix that you need. So what you would do is take off the particulate filtration filter and just put the gas phase filtration with particulate for that period of time that they're re-roofing. So there's no odors coming into the hospital, things like that. The next one that has a little bit more of carbon in media is our matrix structured media. So this is excellent again for retrofits. The only thing with this is that this has no particulate filtration. So if you use that, you either have to, if you have issues with particulate, you have to put a particulate filter either before or after. There's not much dusting that comes off of this filter at all, so you don't have to worry about that. But if you need particular filtration because of the system or where it's located, you're going to do that separately. So the matrix is, when you see through the blocks, you can actually see straight through it, because it creates turbulent air, and the gases get stuck into the walls of each one of those blocks. Usually you can do about 500 feet per minute, but the best is between about 250 to 300 feet per minute for those. From depleted filter to extruded carbon, then we go to our modular units. So the modular units are actual units that we make that have our modules. So we have the PP12s and the PP18s. PP12s mainly used for light industrial and medium industrial, and then the PP18s we use mainly for the commercial side. There's, again, different sizes. This unit right here is called a PFU. That's a packaged filter unit. We can do that for recirculation or pressurization and recirculation. And this is our side access housing that you can put pre-filters, final filters, blowers, no blowers, PP12s, PP18s. You can do 1 pass, 2 pass, 3 passes. So all of those units are very modular. We can change them depending on the need that we have for each application. So we have the side access housing. You have the side access housing that we use for a compressed intake filter. So we have a blower on that unit. We have some kitchen exhaust units, the PFU, the package filter units, and then we have the PFU mobile and the PFU mini. So those are the modular units that we have. From there, you go to deep bed scrubbers. So deep bed scrubbers are bulk filled units. So they're going to be for a lot more higher contaminant load than you would have for the modular units. So they go from a drum scrubber from 100 CFM all the way to 1,000. And then you can, on the radial flows, you can go all the way to 32,000 CFM and sometimes higher. So those are different types of units. There's the medias are in there. They are not in the modules themselves. They are just bulk filled where you're going to put the unit, the media in here. So this is our PBS, the radial flow. This is the V-bank. So it's almost like 2 units into one if you need a higher airflow. Those are our drum scrubbers. Again, those are 100 CFM to 1,000 CFM. And those units sometimes are used in different applications. So you're going to see a lot of the drum scrubbers and lift station and wastewater locations, but we can also do those for industrial. So those are just some examples of our units. So under the industries and applications, we do odor and environmental emission control, indoor air quality, emergency gas scrubbers, and the one that we're going to talk about today is the mission critical, the protection of mission critical electronics, which is corrosion control. So some of the industries there are affected by corrosion, the most affected, I should say, by corrosion. So you have chemical plants, pulp and paper mills, petrochem, mining, steel manufacturers. So all of those data centers, so all of those applications, the industries are places that you see a lot of corrosion just because of the environment that those plants are in. Corrosion on the circuit board accounts for about 30% of all the equipment failures in an industrial application. I mean, that's a lot. So you have to take care of the corrosion to make sure that your system is running properly. Damage and includes disruption of electronic current flow and loss of signal. So acid gases are the most harmful ones, and there's rapid changes in temperature and humidity will also accelerate the corrosion. So in those industries, you're going to see a lot of problems with corrosion. Some areas that require chemical filtration due to corrosion. So inside of those mills, you have motor control rooms. So this is where all the electric motors are in a central location. Drive rooms, you have all the VFDs. Operator control rooms, it's a room where the operator monitors all the operations of the plant to make sure that everything is working properly by using computer controls in there. Rec rooms where they keep all the computers, laboratories, and then administrative buildings. So any place that has sensitive electrical equipment are places that are going to be attacked by corrosion. So corrosion can be, it's a mixture of things that cause the corrosion. It's not just one thing that causes it. So you have atmosphere and contaminants that will cause the corrosion. So atmospheric issues are your humidity, your temperature, and salinity. So your humidity, when you're talking about humidity, it accelerates the corrosion caused by the gases contaminants in an exponential manner. The temperature is something that will affect corrosion as well, and it also can cause local condensation. So that's going to affect. And then salinity, the more salinity you have, it will increase the water conductivity increases. So the higher the salinity, the higher the corrosion rate you're going to have. So if you live close to the coast, you know that your car will get a lot more corroded than a car that lives in a landlocked area. And you can see the corrosion building up on the metal of the car. Same thing happens with electronic equipment. In regards to contaminants, you have three types of contaminants. You have corrosive gases that we already talked about, vapor, and that is also can cause by the condensation, and then dust. All those three things can cause contaminants and can cause corrosion. So again, types of corrosive gases, we're talking about acidic gases like, H2S and hydrogen chloride, hydrogen fluoride, sulfur oxides, and things of that nature. Almost every one of the process industries and heavy manufacturing industries are plagued with bicorrosion on their process control equipment. Just because the environment that they're in has those gases, therefore, if they're not taking care of the environment where the sensitive electronics are, they're going to have corrosion issues. Common sources of corrosion. This is not even talking about the big plants like pulp and paper mill plants that we know has SO2 and hydrogen sulfide. This is just outside in the regular world. You have combustion and automotive emissions, tobacco smoke, cleaning products, airport and jet and diesel fuel. So those are areas that you don't think about that there's corrosive gases. On a kitchen and odor exhaust, you have just from pollutants and food odors and cleaning compounds, all that will cause corrosion. And then, for example, in a GLAM environment, which is the galleries, libraries, archives, and museums, you have just automotive emissions from the streets. You have the artwork and artifacts themselves that desorb, and then those gases are out in there, and material that they use for restoration and cleaning materials, and employees and visitors coming in. So there's a lot of places that you don't think that it's not highly industrial, so you don't think about causing corrosion, but just everyday life, just a lot of places we have corrosion that we're not aware of. So some of the corrosion problems that can be caused by those gases, process controls, communication, and that in itself means that there will be production losses, plant interruptions, accidents. If somebody's running a machine and all of a sudden that machine closes, it stops when it's not supposed to, that can cause an accident. Unscheduled downtime is the main thing. So studies show that unplanned downtime on a single paper machine can cost over $20,000 a minute. And this is, from some of the Avid Solutions website information. So an unplanned mill outage can be over $1 million a day. So that's a lot of money if you don't control that corrosion inside of those plants. So it's a lot of times it's cheaper to maintain the environment clean than it is trying to deal with it unscheduled downtime and having to deal with that after the fact. So this is the picture of a board that has gas phase filtration. It has protection from corrosion. And then this is the one that does not. So as you can see, there's a buildup in corrosion on the elements in this board. So even a gold-plated electronics can be corroded. Because if you think about gold-plated, the substrate of that metal, even though you have the gold on top, the substrate of it still can corrode and oxidize. And then it's porous, so it's going to show through the gold as well. So in regards to corrosion, there are standards how to protect electronics. What are those standards, where they came from? So some of the standards came from ISA, Instrumental Society of America, that was back in 1985. Since then, they have revised that standards. They have revised that back also in 2013. So there's different things that have changed over the years in regards to how to protect electronics. The initial standard came out because some of the companies, the electronic companies that were putting systems out there, were getting flooded with warranty issues. So if they would sell a piece of equipment to a pulp and paper mill, and then within a year that unit would fail. So they would go back to that manufacturer and say, your machine is no good, we need a new one. Some of the companies that were part of the first ISA standards were Exxon Company, the IBM, Hewlett Packard, Dow Chemical, Batcho Corporation. So a lot of those companies had issues with warranty, so they had to create a standard for that. And then back in 2002, there was a European union came out with a directive called RoHS that was lead-free. So most of the machines now that you see electronics, if you buy a piece of equipment, if you buy a computer, it's going to have that initials on it, RoHS, which means restriction of use of certain hazardous substances in electrical and electronic equipment. And that was again in 2002. And that was first one that passed about lead-free regulations in units. So when that happened, it became the boards and all the electronic pieces became more prone to have corrosion because they were not protected by lead. So the classification of, there's different types and levels of classification through the ISA. So the classifications for industrial is a G1 to a GX. A G1 being what you're looking for in that environment. You want to make sure that your area is G1, so the corrosion is not a factor in that environment. And then a G2, corrosion is measurable, but it's still not, it's moderate. G3 is harsh, so you're most likely going to see corrosion attack your electronics, and GX, your electronic is definitely not going to survive. So there's different levels of that, and that is measured in angstroms. So angstroms is 1/10 of a billion of a meter. So it actually is the reading of the amount of corrosion buildup on the metal. Like I said before, on a car, when you see corrosion building up on a car, it almost bubbles up. So you're reading the amount of corrosion that's building up on that metal. So the more it builds up, the higher the corrosion is. So based on a lot of studies, they could tell, the hydrogen sulfide on a G1 was less than 3 parts per billion, but on GX is 50 or equal or 50 or more than 50 parts per billion. Again, so if you do a corrosivity kit, and you see that your kit is reading a G3, and you have chlorine, so your amount of chlorine in that environment is about less than 10 ppb of chlorine for that area. So again, they also have a classification for galleries and libraries and museums. So it's a little different classification that they do for the industrial environment. They do a C1 and S1, meaning a C for copper, S for silver, and then they classify as extremely pure, clean, slightly contaminated, and polluted. So depending on what you have, like museums and libraries, you're usually try to get to a C2 and S2. A lot of times you cannot get to a C1 and S1. In historic houses, just because you can't seal the house that well, a C3 and S3 is okay. C4 and S4 is only short term, and then a C5 and S5 is never acceptable. So depending on what you're trying to do and what application you have, we classified the coupons in a different way for industrial and then for the GLAM environment. Some of the standard practices that you have to do, because I already showed you guys that it's not only the gases that are the issue, you also have to control the temperature and the humidity, the particulate in the gas and everything else. So you have other things that you have to maintain to be able to clean that environment. So temperature, you try to keep that temperature about 70 degrees Fahrenheit, which is about 22 Celsius. It's the ideal. And as long as you don't have more than 2 degrees Fahrenheit up and down, or 1 degree Celsius up and down in a short period of time, then you're okay. So a corrosion rate doubles for every 10 degrees, the change in temperature. So if you're at 66 degrees Fahrenheit, 60 degrees Fahrenheit, you have, or 80 degrees Fahrenheit, you have a lot more tendency of having more corrosion. Again, humidity, you're trying to leave that humidity for less than 50%, and every 10%, you're also increasing that change of rate of 6% per hour. So the other things that you're going to try to do is keep the particulate amounts level low. The gases, you're going to keep that low as well. And the only way you can do that is through gas phase filtration. Now, you can only do the temperature and humidity, the particulate and the gas, if you have maintained that room integrity, meaning seal that room so there's no contaminants coming in. Even if you're cleaning it, but there's contaminants coming in all the time, sometimes it's difficult to keep that room like it should. So a room pressurization, you're trying to keep that at 0.05 inches of water gauge to 0.1. And it's about 3 to 6 air changes an hour. If you're doing a recirculation only, then you're doing a 6 to 12 air changes an hour. The recirculation airflow requirements shall range between 10 and 20% of the volume of the room. And a pressurization is about 5% of the volume of that room. And then, of course, you not only have to do all that, you have to maintain that. So you have to keep monitoring to make sure there's no changes in between, your temperature is not going up, your humidity is not going up, somebody's not opening the door and leaving the door open, and things of that nature. So when you're doing pressurization, some of the basic things that you're going to do is pressurization and air circulation. You're going to have to check the tightness of the area. So if you're thinking about pressurization and we're talking about we're going to have to do 5% of the room, of the area of the room. But if that room is not tight enough, I can put a lot of airflow into that room and it still not get to that 5%. So you need to make sure that room is tight enough before you start trying to clean, because it's going to cost you a lot of money just trying to do that. The more airflow that you do, the bigger the unit is going to be, the more money you're going to spend. So you just need to make sure that the basics are done first. So air tightness of the room is one of the things that you need to check. The contamination being brought in through traffic. If people are opening and closing the doors all the time. The ducts, make sure that the ducts are tight. There's not any openings on the ducts that is going in and out of the room. And then the room walls are in contact with corrosive air, with outside air and things of that nature. So again, relative humidity, keep it less than 50, temperature about 70 degrees Fahrenheit or 22 degrees Celsius, and make sure that's stable. So those are the things that we have to do to maintain corrosion levels low in that area. There's different ways to do gas phase filtration and pressurization and recirc for the room. So if you're doing an outside pressurization unit, inside recirculation, so you would put a most likely a deep bed unit outside, especially if your contaminants are high. You can also put a side access housing with PP12s, and then that will go through your heating and cooling, and then you just do the recirculation inside of that room. So you make sure that the air coming in, the outside air coming in, is clean, is getting heated and cooled, and then you're just maintaining that clean air inside. And the reason that you do the recirculation after you do the pressurization is, people go in and out of this room. There's doors in here. You open the door, there's contamination that's going to come in through the door. That's not just coming in from the outside system. Other way of doing that is if you have the pressurization and recirculation inside of the room itself. So you have outside air coming in, you have your heating and cooling, and then you have your pressurization and air circulation. So in this way, you're not cooling and heating the air that you're bringing in through here. So you're going to have to make sure that this heating and cooling is going to take care of this amount of air coming in as well. So that's one way of doing it. Another way of doing is having all the systems outside of that room. So you have, again, the pressurization unit outside, go through a heating and cooling, and then you have the recirculation going through the temperature and humidity control and going back in. So you're maintaining the temperature and humidity as well as cleaning the outside air coming into that unit. Coming into that room. So like I said before, there's different pieces of equipment, and depending on the amount of contaminants that you have is the amount of is the type of unit that you're going to put in there. A deep bed scrubber on an industrial site is usually a 12-inch bed. On bigger systems, sometimes it's a 24-inch bed. So this is mainly used for a heavy-duty industrial pressurization unit. Then you go to a PP12 cassette, which goes about 250 feet per minute. And as you can see, the bigger the unit, the more media you have, the higher the efficiency is. So if you have a deep bed scrubber, you have about 99.9% efficiency. On a PP12, you start about a 10% efficient, 90% efficiency. PP18, that's mainly used for commercial and pressurization, pressurization and recirc. You're going to start at 80%, but your airflow there, your velocity is about 500 feet per minute, because most of the HVAC for commercial will be running at 500 feet per minute. And then you have the matrix filters, which are your extruded filters that will also start at 500 feet per minute, but the best way to do it is between 250 and 300. So air quality. So we talked about the medias, we talked about the equipment, we talked about how to take care of an area that has corrosion. Now we're going to talk about how we're going to maintain and monitor after we put all that system in, how we're going to take care of that and make sure that the corrosion is not going to change, it's not going to go up. So there's different ways to do that. A couple of ways is the Corrosion Test Kit, which is a corrosion coupon. So this is the copper and this is the silver laminate. You're going to put this in an area for about 30 days. You're going to leave there for 30 days. After you do that, you're going to send that back into us. We're going to read the amount of inksterms build up on that coupon and tell you if that's a G1, G2, G3, or GX environment. So based on that, we can figure out how to take care of that environment, what kind of unit you need there, how much media you need there, and things of that nature. But the main thing here, you definitely have to put the install date and the remove date. Most of the time, you're going to leave that at 30 days. But if you leave it at 15 days and you see that the copper is already black, you probably want to go ahead and send that in to us. So this is a example of a test report. After it comes in, after you send the test in for the coupon, we're going to read that and tell you what the classification is. So in this case, this one was for an industrial use. So it's G1 to GX, and the silver and the copper were at G1. So one of the things that changed in the ISA that I showed you guys before is in 2013, used to be the classification was mainly done by the copper. And then 2013, they decided that copper and silver is going to dictate what classification of that area is. So before, if the silver was a GX, but the copper was showing G1, that environment was classified as G1. Now, if either one of them is classified as a GX, that environment is a GX. So if the copper is a GX, but the silver is a G2, the environment is a GX. And the vice versa. The reason that happens is because gases will affect the different metals in different ways. So a chlorine will probably affect the silver a lot more than will affect the copper. Or if it's summertime and there's a lot more humidity, the copper is going to be affected a lot more than the silver is. So there's different things in the environment that's going to affect the metal in different ways. This one is the report that shows the GLAM, which is the galleries, libraries, museums. So this is a different classification that I showed you guys before as well. Go from S1 to S5 and C1 to C5. So on this particular one, you have your copper at C2 and your silver at S1. So this area is classified as a C2 area. Other ways to monitor and test the media, we have, I already showed you the corrosivity test kit. That was the coupon that I showed you. And then we also have an electronic version of that that's going to read the temperature, the humidity, the copper, the silver, and also the pressure, the room pressure in that area. So that is, so the copper and the silver sensors are in here, and that is going to tell you online at all times what the room is doing. So you can have that on a Wi-Fi, for example, and you can log in and see exactly what that room is doing. Other things that we can do is media testing. So after you put the unit in there, you want to make sure that the media is still working properly. So we have a media bed rod that you put in, and then as the corrosion, as there's breakthrough, the corrosion will build up into that. And then there's marks on that rod that is going to tell you when it's time to change. Another simple thing to do, if you have potassium permanganate, the purple pellet, is just looking at the color. It's not 100% safe to do that, but you can do that. You can send the media in for media life analysis. And then the other one that we have is electronic media bed monitor, which is an electronic version of this rod, where actually it's going to read how much gas is going through there. So some of the solutions, the main points that we need to keep in mind is when you're doing pressurization, we're going to try to keep that pressurization at a 5% of the room volume inside of that room. And that is pressurizing the air with the clean air with gas phase filtration units. So you also have to dehumidify and cool and heat before is entering that room. And then if you're doing recirculation, again, you're going to have to cool and heat that air and then purify through the media and the modules as well. So to provide a full solution, and that is with the equipment, that is with the media, that is with the monitors, you're going to identify the problem that you have. And then we're going to design the appropriate solution based on the range of products and customer requirements, and then follow through the implementation of the solution. And then always continuous monitoring that environment to make sure that the system is maintained and the media is still good. So those are the things that we have to do. So when we're trying to figure out the best solution for the customer, we need to know exactly what the problem is and how they're trying to solve it before we can put a system that's going to work in there. So some of the things that you have to consider when you're putting a system together is the type and the level of contaminants. So the more information we have in regards to, what gases they have, they know what the ppm levels are, the ppb levels. What is the temperature and humidity? Are they maintaining that? Are they making sure that that's not fluctuating more than 10%? a day at 70 degrees Fahrenheit or 22 Celsius? What is the room volume? The airflow. I mean, we need to know what the room size is, so we know the volume of the room is. What kind of condition is the room? Is it 100% sealed? Is it a new construction? Is it not? Are we doing pressurization or recirculation? Is there any space restrictions that people going in and out? So all those things is the items that we have to think about when we're putting a system together. Is there a particular filtration already inside of that room that we don't have to worry about? And then also how we're going to continue monitoring the environment after we put the solution together. All right, so I'm done with my part, and if you guys want to have any questions, you can put on the chat, or you can raise your hand and I can take a look at that if you have any questions.